You've been using closures this whole time, and you probably didn't even realize it. But the big problem is when you're asked about them in an interview and your mind goes blank. So let's fix that. Before we get into closures, you have to understand two key concepts, and that's lexical scope and how function and memory work together. So what exactly is lexical scope? It's simply when an inner function is trying to access a variable created in the outer function. So in this case, the function inner is incrementing this counter variable created in the outer function. So if you run this code, you'll find 1 because this uses lexical scope. This inner function is accessing a variable created in the outer function. Now, what would be even better is if you ran this function multiple times. And after multiple times, you get from 1 to 2 to 3. But in this case, it won't work. And that's because the way function execution and memory work together. All right, well, we're back to the drawing board. See, the way this works is that whenever you execute a function, it runs line by line. And so it creates this counter variable. Then we execute this whole inner function. And in this inner function, it uses lexical scope to access the counter variable, increments it by 1, and then logs it to the console. After that, there's no more code to run, which means that this function has completed its execution. Now, once this function completes its execution, this counter variable is removed from memory, so it doesn't exist anymore. So when you call this function again, it recreates this counter variable completely. And that's why you get 1, 1, 1 instead of 1, 2, 3, because every time we call this function, this counter variable is recreated entirely. But there is a way to fix that, and that's by using closures. Now let's take a look at an example of a closure, and it's very similar to our previous example. There was one key difference though. Instead of immediately calling that inner function, instead we return that inner function. This way, after this function has finished executing, we can use that inner function outside of it right down here. But now that you understand function execution and memory and how they work together, you know that as soon as you call this function, it creates this counter variable. And because we're returning a function instead of calling it, there's nothing else for our outer function to run. So it finishes its execution. And when a function finishes its execution, it removes this variable from memory. So it doesn't exist anymore. But our inner function relies on this counter variable right here to increment it and to log it. So if our counter variable is deleted and our inner function relies on it, then when you call this inner function, it should throw an error, right? Well, let's see what it does. We're going to call that inner function 3 times. So if you run this, you actually do get 1, 2, 3. But how does that happen? Any questions, let me know in the comments below and I'll do my best to answer them. And in the description, there's a GitHub repo full of real world examples with a bunch of comments explaining everything. And while you're down there, you might as well subscribe. Well, the reason why that happens is because you're using what's called a closure and you don't even realize it. You see, when an inner function is used outside of the execution of the outer function, like we're doing here, and it relies on the variable created by that outer function, it doesn't remove that variable from memory. Instead, it puts that variable inside of a little box. So now when you call this inner function, it's not creating an entirely new counter variable. Instead, it reaches into that box, and that counter is currently at 0, and it increments it by 1. And then you call that inner function again, and it reaches up inside that box, and it increments that to 2. You see, the key thing to remember here is that this counter variable is never removed from memory. Instead, it's put aside in a little box so that this inner function can continue to access it, and that counter variable's value is never lost. And when you put that variable inside of a box, that's what's called closing over. You're just putting that variable inside of a little box so that this inner function can maintain access to it. That's just closing over a variable. Knowing why and how closures are created is so important because you can unintentionally create one and cause a memory leak. So this example is a little different from our previous example. That main difference is that we don't return an inner function. Instead, we have this set interval. Now, this is still the closure. You execute the closure function and you create a counter variable. Then you create this set interval. And after every second, you're going to increase the counter and then log it to the console. Now, as soon as this set interval has been created, it's going to be pushed over to the side, running separately from this main outer function. So instead of running in our outer function, Instead, it's going to run in this little side area over here. This set interval still relies on this counter variable. So what's JavaScript going to do? It's going to close over this counter variable so this set interval can still use it. So now if you run this code, every second this counter variable is going to increase by 1. But here's the problem. This function will run forever. And if this function runs forever, eventually it's going to cause a memory leak. So to combat this, you have to clean up these long-running processes that are closures. So here's how you do that. You're going to store this set interval in this interval variable. And just like before, you're going to increase counter and then log it to the console. Then you're going to check if counter is equal to 5. And if it is, you're going to use this built-in function, clear interval. And you're going to pass this interval variable into this clear interval function. So if you run this code, every second it's going to increase this counter variable. But this time, as soon as it reaches 5, it's going to clear the interval and stop. Now this clear interval is only specific to set interval. So with whatever long-running process that you're using, you have to find out how to clean that specific one up. Now closures are a tricky topic, and it took me a long time before I completely understood them. So check out that GitHub repo with real-world examples to deepen your knowledge, and then build something great.